There's one more trick for calculating limits that shows up every once in a while, just often enough to have a look at. So here's a limit that we could try to evaluate. So limit as x goes to 0 of x times cosine of 1 over x. Now you might think, well, look, there's a product here, so why don't we use the limit laws, right? The product rule for limits says this is the limit as x goes to 0 of x times the limit as x goes to 0 of cosine of 1 over x. But what you'll find is that this second limit, the limit as x goes to 0 of cosine of 1 over x, actually doesn't exist. So if you graph it, it looks something like this, and then near 0 it just bobs up and down infinitely many times, and that means this limit doesn't exist. But to use the limit laws, both limits have to exist. Well, this one doesn't, and that means that you can't actually use the limit laws. So we're kind of stuck. We might get some ideas by looking at the graph of this function, x times cosine 1 over x, and here is that graph. You might think, well, let's zoom in and see what happens, but in fact, zooming in doesn't really change the situation. There's still just so much bobbing up and down near 0 that it's just hard to tell what's going on. There's sort of too much going on near 0 for us to ever trust that we're calculating the correct value or guessing the correct value. So what can we do? Well, there's one interesting thing about this function, x cosine 1 over x. The interesting thing about this function is that we can tell in general how big it is, right? This cosine part never gets bigger than 1 and never gets smaller than minus 1. So that means that this function is always less than or equal to absolute value of x times 1, right? Because this part, x, is never bigger than its own absolute value, and this cosine part is never bigger than 1. And so the product of them is never bigger than the product of their individual bounds. But we can do the same thing on the other side. So x is never smaller than, x is never smaller than the absolute value of x, and cosine is never smaller than minus 1. So this product is never smaller than the negative of the absolute value. So I've got an extra line here. All right. So our function, x cosine 1 over x, is stuck between these two functions, right? In fact, if we graphed these two functions, the one on the left here, negative absolute value, looks like this. And the one on the right, I'll do it in green, absolute value of x, that looks like this. And you can see that our graph is stuck in between these two. And we wanted to know about the limit of this function, x cosine 1 over x, but we decided it was too hard. Well, we know that our function is trapped between absolute value of x and negative absolute value of x, so what's the limit of these two functions? So let's take the limit of both of these as x goes to 0. Well, clearly as x goes to 0, its absolute value also goes to 0. And as x goes to 0, the negative of its absolute value also goes to 0. But if both of these limits are going to 0, right, this one is going to 0 and that one is going to 0, our function is trapped in between the two. So even though we can't sort of zoom in infinitely far to see what's happening to the blue graph here, we know that it's getting pinched between the green and the red, and those are both going to 0. So there's nowhere else for this to go when we take the limit but to 0. Okay, so this limit, it's 0. And we can tell it's 0 because it's trapped between these two functions, and they both go to 0. So this general phenomenon is given the fancy name, the squeeze theorem. And when you write it all out with symbols, it looks like it's saying something a lot more complicated than it actually is. So the sort of technical way to say it is that if you have some functions that are defined on an open interval around the place where you're taking the limit, a, and the outside functions have the same limit, and g is stuck in the middle, then the limit of g is also that middle value, also the same value. You can see this is just sort of a a symbol-heavy version of saying what we just said with this example. We have one function trapped between two outside functions. The outside functions have the same limit, and so the middle function has to also have the same limit. That's called the squeeze theorem. This is often a convenient way of calculating some tricky limits like this that involve trig functions when the trig functions wiggle around too much, right? The problem with calculating this limit, the problem with our first way of calculating this limit was that because the trig function wiggles around so much, it's sort of hard to keep a handle on what's happening, right? So using the limit laws directly failed. But because cosine is bounded by +1 and -1, that let us put nice bounds on the product, x times cosine whatever x, and that let us use this squeeze theorem because the outside functions are sort of pinching our function and forcing the limit towards 0.